Guys, Pranav here, and today I'm going to be showing you how I use the audio graphing calculator, a software to plot graphs, to be able to listen to graphs, plot them, and just work with them. So graphs are very important because they let you visualize certain data. They let you visualize it over a period of time. I use it for the same purpose. I use it to visualize shapes of curves such as parabolas, cubics, and exponential curves. I use it for trigonometry, and I use it because I want to visualize certain other data that I've either got in a question from school or from some other project that I do. However, using stuff like the graphing paper is not always convenient because A, I can't always carry it with me as it's kind of cumbersome, and also B, because it can't display values with great levels of accuracy due to just size limits. So here's where the graphing calculator comes in handy because I can plot graphs, as I said, and listen to them. And that's what I'll be showing you here. So you can get this software off Google. And for my screen reader, I am using NVDA. So I'm going to navigate to the audio graphing calculator. And here we have a few tabs. We've got the plot screen, which helps you configure settings.
Wave screen.
That's for configuring certain sounds. You can navigate through these screens with the left and right arrows.
Speech screen.
This is to configure the sort of self-voicing.
Calculator screen.
This is a scientific calculator.
Data 1 screen.
Now there are two data sets that you can plot to sort of do comparisons.
Data 2 screen.
That's data 2.
Evaluator screen. Matrix screen.
Evaluator and matrix are stuff that I personally never
Calculator
use,
screen.
so I don't really know.
Data 1 screen. F open parent.
Okay, so here we have this data. So we've
Data
got,
F open parent X close parent.
that's where you can type your function. I'm hitting tab.
Coordinates button radio button rectangle checked.
That's the type of coordinates you want from your function.
Button statistical description of dataset.
And that gives you sort of a description. So we're going to plot a few types of graphs. The first one is a linear. So let me just do x
plus
plus 5. I hit enter and it evaluated. Now, the first thing I'm going to do is hit F3 on my keyboard to show the graphs. For all the F keys, users with a laptop will have to hit the function key as well.
Graph open.
The graph should be open now. And now if we hit F5, it'll actually play the graph. So let's listen to this curve. So you can really see that it shows you sort of the shape of the line in this case. It's a straight line. Let's do another one. Let's do a parabola. Let's do x squared.
X to the power of 2.
That would sound like this. So it's a very smooth curve.
Backspace 2.
What about a cubic? X cubed.
X to the power of 3.
Sounds like this. I kind of like that sound, to be honest.
Backspace 3.
Let's do a fraction. So 1 by x.
1. Divide x.
And if I hit enter, and now I have 5. The reason this sounds so weird is because it starts out above the x-axis. It never really touches the x-axis, but it dips just before 0, and then it goes right back up after 0 in the second quadrant.
Backspace
So
x.
let's do an exponential, so 2 to the power of x.
To the power of x.
But for the to the power of, or the superscript, by the way, I'm using shift plus 6, which is the caret symbol. And if I hit F5, so it's sort of slightly going up very, very slowly, and then it suddenly goes up because it's an exponential curve. So each time the curve gets steeper. Lastly, what if I want to plot like a sine wave, which does have a function, but it's kind of ambiguous, right? What if I want to plot the points directly? Because let's face it, that's easier. And this is a common occurrence because many a times I have data that I have values for, but do not have a function that generalizes the data. So I can plot in points. What I'm going to do is type in points equal to 9.
P-O-I-N-E-S. 9.
You won't hear a beep when I press enter, but now if I tap twice,
X equals cell contains no data.
We get a table.
F of x equals cell contains no data. X equals cell.
X and f of x. So I'm going to quickly enter the values.
0. X equals 0. F of x equals 0. F of x cell contains equal.
This is
4, 5, x equals
45.
f of x equals 45.0, f of x equals
This is
0. 5, f of x equals 0, second x equals
0.5. This is
9, 0,
90.
x equals 9, f of x equals second
This is
1, f of
1.
x second x equals
This is
1, 3, 5, x equals 1, f of x
125. This is
0, 5, f of x
0.5.
equals second x equals
This is
1, 8,
180.
0, x equals 1, f of x equals
This
0,
is
f of x equals
0.
second x equals 2,
This is
2, 5, x equals f of x
225. This is
minus 0,
minus
f of x equals 5,
0.5.
backspace 5, minus 0,
Minus
5, f of x equals
0.5.
220, f of x equals minus 0. Second x equals 2, 7, 0, x equals 2, f of x equals second minus 1, f of x equals second x equals 5, x equals 3, f of x
315.
minus 0, 5, f of x equals second
Minus
x equals
0.5. And
3, 0,
finally,
x equals 3, f of x
and
0, f of x
0.
equals
Now, because I'm on this table, I need to actually hit F4 to evaluate because I'm not in that edit box where I can just hit enter. So if I hit
f
F4,
open parent x close parent user
takes us back to the edit box. And now if I hit F5, we hear this. The reason it sounds like a telephone with someone pressing random buttons and not exactly like a smooth curve is because I've plotted points directly. Had I actually used the function for sine x, it would have actually looked like a smooth wave. But essentially, that is how I use the audio graphic calculator. Again, very useful tool. Really, really helps me when I either just want to see a curve for myself or listen to one, or show a graph to my friends or at a presentation. I hope you found this useful and enjoyed it. And I'll see you later. Bye.